Hello again. In this module, we're going to discuss more on the Azure machine learning, that is, machine learning on the cloud of Azure. So it called as Azure machine learning. In this, we should have an Azure subscription. After we have the Azure subscription, we should have create the Azure machine learning workspace. That is a logical container. Under this logical container, we will be having compute data, experiments, models, and services. We're going to discuss about each and every term. Compute. Compute is like a virtual machine, or you can say who handle the workloads. So in the workspace, we'll create a compute so that our load can be handled easily. The other is data. This is the data which we use to feed to our model so that our model can be trained. Next is the experiments. We create a lot of experiments, and based on those experiments, the prediction will happen. We can have a multiple experiments. So when we have a optimized experiment, which we can say that, okay, this experiment works awesomely well, then we can use that experiment in the model to have the appropriate results. Next is the models. This is the machine learning model. In that model, we're going to use the data and experiments and compute too. Based on this model, our Based on this model, our machine learning will be predicting by the data which we fed earlier. This model can be trained first. Once training is done, we're going to publish it. That is the services. We are then After it is published, then we can see the actual results. So this is the workspaces. Under the workspaces, we have this. This is a graphical representation of this. In the end, if there's some mismatch in the data, I think it's the word is being cut. So that is an Azure subscription in the end. Under the Azure subscription, we have the Azure Machine Learning Workspaces. Under the Machine Learning Workspaces, we have the Compute Data Experiment Model and Services, which we already discussed. So this is how the workflow will look like. Under your subscription, we'll have a machine learning workspace. Under the machine learning workspace, we have compute data experiment model and services. This is now we're going to discuss about the automated machine learning. In this, data is ingested into the model so that it can be trained. In automated machine learning, there are a lot of set of algorithm already presented over there. You just need to select it. Some algorithm based on the regression, some classification, and some on the cluster. You can select based on your need. So there's a flowchart diagram. First is the data. The data will be processed. After the processing of the data is fed into the model. So data will be, you can take the data from any of the data is a raw data, and you can take it from any source which you have. Then at the process step, the data will be ingested to the model, and the processing time, it means that the data is ingested or fed it to the model, and this is how your model will be training up. So this is a overview flowchart. Azure Machine Learning Designer. We have two machine learning. First is automated machine learning, which we already discussed, and the other one is Azure Machine Learning Designer. This is the place where you can create pipelines. It's a visual tool for creating pipelines. That is a drag and drop feature. If automated machine learning doesn't give the result which we expect, we can build our own Azure machine learning model and train it using Azure Machine Learning Designer. That is a pipeline. It's a visual drag and drop. In this, you will have a more control. So, in the automated machine learning, we discussed that it's completely automated. We select the algorithm which is already presented over the cloud. But let's say that is not fulfilling your requirement. That is, the data which you expect is not coming as exactly as you want, then you can use the machine learning designer. In this, you can create your own pipelines, your own customized tool so that the data can be processed. So everything will be, you are the one who are creating this. Of course, there's no need to write a code. It's just there are predefined available data sets which you can use it, or the predefined algorithm is presented, you can use that. But you just need to design your own by using Azure Machine Learning Designer. Here, first we create a training pipeline which will train the model. Then we create an inference pipeline. So first we create a normal pipeline. In that pipeline, we'll normalize the data and then train the data. Once the training pipeline is created, we'll create an inference pipeline. Inference pipeline means that how pipeline should process when we have a new data, or you can say the prediction pipeline, which is used to predict with new data. So the training pipeline is a pipeline which is used for training of the data which you have, and the inference pipeline is for validation, or you can say the prediction. This is a with the inference pipeline, the prediction will happen when you have the new data to feed into the model. Then we're going to deploy the pipeline as a service so that application can utilize it. Like here, we will have the API or the codes automatically generated by the Azure. We just need to put that code into our application. That's how simple it is. So you can make your application machine learning enabled. We're gonna show that in the demo at the end of this session. Here, so once you have the code, just put into the application and that application will be machine learning enabled and it will be using the machine learning designer or an automated machine learning. In this, we're going to discuss compute instance that we discussed. So, a compute instance is a VM where the compute will be running, the notebooks will be running on the VM or any code related to the machine learning. It will act as a workstation of yours. So all the processing while running the notebooks, having the Python code or anything will be processed in the node in the compute instance. This is a place will it will take care all of your workloads at the compute instance. Next we have a compute cluster. If you would like to scale up or down for one of your compute resources, that is at that time when you would like to train or test your model with a lot of data, then you can scale up the cluster. You can consider the cluster as an auto-scaling concept on cloud. That is, whenever there is a lot of data coming up, then you would require to increase the compute resources because at that time you are feeding up more and more data into your compute. So you can scale it up by using compute cluster. So in that cluster, if you require more compute resources, then it automatically spin up more compute resources for you. Inference cluster. We will use this cluster in order to deploy the model and then we can use from the client applications. Inference cluster is generally used for the deployment of the model. Once it is deployed, we can consume it at the client application. So inference cluster is just for the deployments. When we have everything is ready, we want to publish it. Then we have the attached compute. If you would like to attach the compute like Databricks cluster or SD Insight cluster, then we use the attached compute. Let's suppose you have a very big compute clusters, a very big clusters of Databricks and SD Insights which have a lot of data presented in that, and you would like to use that so that you will not have to create a new compute instance because you already have owned Databricks cluster and SD Insight cluster. So you can attach that compute with the Azure Machine Learning under the attach compute so that that cluster which is already exists can be easily used. Now it's time for demo.